Let us solve a question on utility function. The question is, if u is equal to q1 raised power a times q2 raised power b is a utility function of a consumer where q1 and q2 are the amount of two commodities, and if y is the fixed income which is spent on purchase of these commodities, then show that q1, that means demand of good q1, is equal to a times the income divided by a plus b times p1, and quantity demanded of good 2 is being given by this very term where p1 and p2 are the prices of q1 and q2 respectively. Okay, so basically what we are being asked to do, we want to maximize this utility, and let me write it here. We want to maximize u is equal to q1 raised power a times q2 raised power b, subject to the budget constraint. What will be the budget constraint? Simply price of good 1 times units of good 1 plus price of good 2 times units of good 2 should be equal to income. Okay, so income is being denoted by y. Okay, we want to maximize this utility subject to this budget constraint. And on graph, what exactly is meant by this? So if we have q1 on this side, q2 on vertical side, given the budget line, and let's draw the budget line, we want to maximize our utility. That means we want to reach to the highest possible indifference curve, and our highest possible indifference curve will be tangent to the budget line. Okay, and this will be our utility maximization problem. We need to find out the demand function for q1 and q2. Okay, so when IC and budget line are tangent to each other, at that point, our marginal rate of substitution MRS between Q1 and Q2 should be equal to the ratio of the prices. This condition must hold here. Okay, that will give us the optimal bundle of Q1 and Q2. So let's write it here. First order condition for maximization requires that marginal rate of substitution between Q1 and Q2 should be equal to the ratio of the prices, that is P1 upon P2. And MRS is simply marginal utility of good 1 divided by marginal utility of good 2 should be equal to P1 upon P2. Okay. Now MU1 means the partial derivative of utility function with respect to Q1. Given this utility function, if we take partial derivative with respect to Q1, derivative of q1 raised power a will be equal to a will become coefficient q1 and exponent will be subtracted by 1, and q2 will remain same because we are taking partial derivative with respect to q1. Symmetrically, marginal utility of q2, let's denote it by mu2, will be that partial derivative of utility function with respect to q2. Again, we are taking derivative with respect to q2. The exponent of q2 will become coefficient, so we will have a, q1 will remain same, raised power alpha, and q2, its exponent will be subtracted by 1. Okay, now mux upon mu1 upon mu2 will be equal to, so mu1 divided by mu2 should be equal to the ratio of the prices p1 upon p2. Our mu1 is this function, that is a q1 raised power a minus 1 times q2 raised power b. mu2, that means marginal utility of good q2, is equal to, here actually we have b because b will become coefficient here in this function, so we have b q1 raised power a times q2 raised power b minus 1. It should be equal to the slope of the budget line, which is being denoted by p1 upon p2. Now if we solve this, let us see here, a divided by b will remain same. If I transpose this term to denominator, what will happen? So in the denominator we have q1, sorry, let me write it here. We have q1 raised power a. If I transpose this term, it will get multiplied with this q1, but exponent sign will change. If it is here a minus 1, it will become minus a plus 1. Okay, and if I transpose, so in the numerator we have q2 raised power b. If I transpose this term to numerator, it will get multiplied with this q2. That means we will have q2, but exponent sign will change. We have b minus 1, it will become minus b plus 1. Basic rule of indices, minus b plus 1. Okay, now when we add up, bases are same when we add the exponent. So what is the exponent here? We have b minus b plus 1, so we will get the exponent equal to 1. In the denominator also bases are same. If we add the exponents, we will get a minus a plus 1, so our exponent will be 1. So what we are being left here, so in place of q2, sorry, we will get q2, its exponent is 1, so we will write only q2. Here we will have q1, a I am picture q1, and to this we have a divided by b should be equal to p1 upon p2. Okay, let me rub this out. I was just trying to explain here. So solving for either q1 or q2, let us solve it for q2. So q2 will be equal to p1 upon p2. Okay, transposing this, it will get reciprocated b upon a, and here q1 will get multiplied a q1. Now simply plug the value of q2 back into the budget constraint. What is budget constraint here? Okay, so we have p1 q1 plus p2. In place of q2 we have p1 divided by p2 times b upon a q1. So p2 gets cancelled, and it is equal to y. What we are being left here, let us take p1, or rather let's take, okay, let us see what we can do here. So we have p1 q1 plus p1 q1, and we have b upon a is equal to y. Let's take p1 q1 common. If we take p1 q1 common, what we are being left with, 1 plus b upon a should be equal to y, which implies it will become a plus b divided by a. Now we have p1 q1 here. Okay, p1 q1 or our p1 q1 will become, it will become a plus, or let's write it here, parishani, a plus b divided by a is equal to y, or q1 is equal to, okay, q1 will be equal to, let us see what happens here. We will get y, transposing this, it will become a divided by, rather let me write it here. So this will get reciprocated. We will get a times y divided by a plus b. Okay, this p1 will get divided. That is q1 is equal to this term. Okay, now to solve for q2, and let's write it here. To solve for q2, so our q2 will be equal to, let us plug this value of q1 is equal to this in this equation. So our q2 will be equal to p1 upon p2 times b upon a. In place of q1 we have this ay divided by A plus B times P1. P1 gets cancelled. A and A gets cancelled. We are left with Q2 will be equal to B times Y divided by A plus B times P2. Okay, so this is demand function for Q2.